When you look up at the night sky, it's easy to think you're seeing everything. Stars twinkle like pinpricks in a blanket. A few planets shimmer faintly. Maybe a moon, maybe a galaxy if you know where to look. But the truth is, you're not seeing the universe. You're seeing the barest sliver of it. The human eye can only perceive a narrow band of light called visible light. Most of the cosmos is invisible to us. It exists in wavelengths too large or too small for our eyes to detect. Infrared, ultraviolet, radio, X-rays, gamma rays. Entire galaxies hum with signals we'll never see unless we build machines to translate them. And we did. Telescopes like Hubble and the James Webb Space Telescope have peeled back the veil. They showed us those tiny dots of light. They're not stars, they're galaxies, billions of them. Each contains billions of stars. Each star is potentially surrounded by worlds. Our sun is just one among them, an ordinary star in an ordinary galaxy. Already, our imagination begins to buckle, because the deeper we look, the more we realize. The universe is not just big, it is impossibly, relentlessly vast, and we've only just begun to understand what that truly means. Let's talk about distance, not in kilometers or miles, but in something far more surreal: light years. One light year is about 9.46 trillion kilometers. That's how far light travels in 1 year. And remember, light moves at 300,000 kilometers per second. The moon is just over a second away at light speed. The sun, 8 minutes, but the nearest star system, Alpha Centauri, is over 4 light years away. That's more than 40 trillion kilometers, and that's just next door. Our galaxy, the Milky Way, is 100,000 light years wide. If you could fly at the speed of light, it would still take you 100,000 years to cross from one side to the other. And beyond that, the Andromeda Galaxy is 2.5 million light years away, and that's the closest spiral galaxy to us. But these aren't even the big numbers yet. The observable universe stretches 93 billion light years across. We say observable because that's all we can see. The universe itself may be infinite, or it might loop in on itself. We don't know. The more we measure, the more absurd it becomes. We're not just a speck in the cosmos. We're a speck on a speck, lost in a sea of space-time so vast it defies numbers. And yet, it's real. This is the universe we live in, and we've barely stepped off our doorstep. When you think of a galaxy, picture a swirl of stars, millions of them, glowing and spinning in a cosmic dance. Now multiply that by 100 billion. That's how many galaxies are estimated to be in the observable universe, and each of those galaxies contains billions or even trillions of stars. Not empty voids, but stellar cities, crowded with suns, planets and mysteries. Imagine scooping a handful of sand on a beach. Each grain represents a galaxy. The beach, the observable cosmos. Galaxies aren't evenly spaced. They gather into clusters, superclusters, and immense filament structures. The universe has a web-like shape. Massive voids stretch for hundreds of millions of light years, cosmic deserts where almost nothing exists. Meanwhile, vast rivers of galaxies snake across the dark. The Milky Way is part of the local group, which sits in the Virgo supercluster, which in turn is part of the even greater Laniakea supercluster. It's a Russian nesting doll of scale, and somewhere in all that complexity, our pale blue dot orbits a modest sun. Every image taken by our deepest telescopes is a time machine, showing us galaxies as they were millions or even billions of years ago. Some no longer exist, but their light still travels. The stars in our sky are just the surface. Beyond them lies the architecture of everything. The farther we look into the universe, the older it gets. That's because of the speed of light. We're not just looking across space, we're looking back in time. When we observe the Andromeda Galaxy, we see it as it was 2.5 million years ago. Light from it has only now reached us. We see stars that no longer burn, galaxies already dead. Our deepest telescopes glimpse the first light, the glow from just after the Big Bang. The universe has a horizon, not because space ends, but because time limits what we can see. The James Webb Space Telescope is peering farther than ever, 13.5 billion years into the past, just a few 100 million years after everything began. So when you look at the night sky, understand this: you're not seeing the present, you're seeing ancient history. The cosmos is a living archive, a memory etched in photons, and our planet, our species, our entire history fits in the blink of a cosmic eye. Time and light are woven together. To understand one is to embrace the other. The deeper we gaze, the farther back we go, until eventually we reach the birth of it all. And beyond that, darkness, silence, the unanswered. What lies at the edge of the observable universe? Not a wall, not a barrier, but a limit set by time itself. The universe is about 13.8 billion years old. That means we can only see objects whose light has had time to reach us in that span. But because space itself expands, those objects are now much farther than 13.8 billion light-years away. The cosmic horizon stretches nearly 46.5 billion light-years in every direction, forming a bubble 93 billion light-years across. Beyond that, we don't know. Possibly more of the same, possibly something different. Maybe the laws of physics bend, maybe they break. But this isn't the end of existence, just the end of our vision. And what we do see is staggering. Ancient galaxies frozen in their youth, light from the first stars, cosmic microwave background radiation, the afterglow of the Big Bang stretched across the sky. Our edge is not a border, it's the beginning. And as we push our instruments farther, our understanding deepens. Each new observation adds another piece to the cosmic puzzle, but there will always be more we cannot reach. Not because we're unworthy, but because the universe is too vast to ever fully hold. That's not a flaw, it's the beauty of it. Space is not flat, time is not constant. This is the strange truth revealed by Einstein's theory of general relativity. Mass bends space. The more massive the object, the more space-time curves around it. Planets orbit stars not because they're pulled, but because they roll through warped paths in a cosmic fabric. Time moves slower near massive objects. Stand on the surface of a neutron star, and a second would stretch compared to time on Earth. Black holes stretch this distortion to its extreme. Inside these monsters, space collapses. Time halts. The laws of physics as we know them disintegrate. This means the universe is not just big, it's strange. A place where gravity is geometry, where light can be bent, where time is flexible, and this bending happens everywhere. Your body, your home, your planet, all subtly warping space. It makes the scale even harder to grasp, because distances don't behave. Light doesn't travel in straight lines, and time is not universal. The universe is not just beyond our reach, it's beyond our intuition. Yet with math and machines, we follow its twists. We don't just observe the cosmos, we interact with its very shape, and perhaps someday we'll learn to ride those curves. Here's the question that haunts every astronomer, every philosopher. What lies beyond the observable universe? If we could step outside our bubble, what would we see? More galaxies? Parallel universes? An infinite void? Some theories suggest the universe is infinite, that we're just one patch of an endless cosmic field. Others propose we're in a multiverse, one of countless universes, each with its own laws of physics. We may never know. The light from beyond that boundary has not and may never reach us. Our knowledge is bounded by light, by time, by the speed of causality itself. But in some ways, that makes it more wondrous, because every time we thought we'd reached the edge, we hadn't. We once thought the sky was a dome, then a sphere, then a galaxy, now a web of trillions. Each discovery has humbled us, and each time we asked the next question. The universe doesn't just stretch outward, it stretches us, and in that pursuit, in that reaching, we become something more than just matter. We wonder. The universe is massive, unimaginably so, but perhaps the most beautiful part of it is that we're trying to understand it.